So. Yo, hello and welcome to our 10th GDTA powwow session here in May. And welcome from Germany, from Potsdam. Actually, I'm sitting in my home office here right now. My name is Uli Weinberg. I'm director of the School of Design Thinking and also the co-starter of the Global Design Thinking Alliance, which is an association and alliance of more than 20, I think it's 22 organizations around the planet, 5 continents, who are all dealing with design thinking. And it's mostly academic institutions. And we decided during the pandemic, and you have seen our pandemic-driven little trailer here for our event, we have started a series, an online series, kind of monthly, in a monthly rhythm, and joining or celebrating actually our members. And we do this in an open Zoom call, and I would love to all of you, I would like to see you here switching on your video right now. Since I'm also welcoming Steffi Schwertfeger, who is organizing all the time the events. Steffi, if you could, yeah, there's Steffi and Anna. Anna, where is Anna? I don't see her. Yeah, over there. Anna is helping us to get all the people in the call. She's our digital concierge today. And maybe, Steffi, you could show the next slide here, which is about our netiquette. So we'll have our guest, Matt Parkinson, pretty soon. The plan is that he is giving a talk for about 30 minutes, maybe a little bit more, I don't know, but that is usually how we try to divide the time, the 60 minutes here. Then you are, of course, welcome to ask questions in the chat in the meantime. And raise your hand later for the discussion after the 30 minutes of intro by Matt. And actually, he brought a colleague, Jessica Menold. Jessica Menold, yeah, here. After the 30 minutes, there is an open discussion. So ask your question. But during that time, during the talk, please switch off your video. I do the same pretty soon. And because we are recording the whole thing, it is good to have just the speakers, the speakers and their presentation on the recording later. And also welcome to our friends on YouTube. We are streaming it live, and we're streaming the full hour. And after the hour, we have a kind of fireside chat. In this case, I think fireside chat is the wrong term, because Matt Parkinson, who is our special guest today, he is not at a place where fire is a good thing to have, because he has a lot of sun around him. He is on vacation, and he is probably able to show us a little bit later his incredible environment, his incredible not virtual background he is right now. So Matt Parkinson, he's one of the founding members of the Global Design Thinking Alliance. When we did our Decon Festival in 2017, and he's usually, when he's not on vacation, and he is very seldom on vacation, actually, he is a professor of engineering, design and mechanical engineering at Penn State. and where he's also directing the Bernard M. Gordon Learning Factory and the Center for Research and Design and Innovation. And I know Matt since quite a while, and especially with his record in project development and project-based learning, because I think he is the world leader, the world champion in project-based learning. I don't know any other person who is able to run more than 200 projects every year, 200 partner projects. So we do a lot already at the D-School in Potsdam. We have 16 every semester, which ends up with 32 or so, but 200 projects a year is like unbelievable. So, and I'm happy to have him as a guest today here. And together with Jessica, they will talk about the interesting things they are doing at Penn State, and also about, I think you give us also a little glance about the new building, which I haven't seen yet. And so please welcome together with me, Matt Parkinson and Jessica Dolores Menold. Welcome, the stage is yours. And please switch off your videos to all of our guests.
Excellent. Well, thanks for that very generous introduction, Uli. It's good to be with everybody. We have been involved with Uli and HPI and various partners of the Global Design Thinking Alliance for many, many years now. And it's one of the things that I personally very much enjoy. I love learning from you and participating in your different activities. And you'll see later on how some of you have played very important roles in my experience here at Penn State. As Uli mentioned, I'm joined by Jess Menold, who has also been affiliated and associated with HPI for many, many years, and who is a leading researcher in design thinking, and in particular around the hands-on learning activities around design thinking. And she's going to share some of the really cool pieces of her work here in a little bit. So I just want to tell you a little bit about who we are and give you a little bit of background on us. So we are the Learning Factory. First of all, it started out as just a little facility. It's a little shop. And over 25 years ago now, it was just kind of the place in the College of Engineering where students could come and work on their projects. But since then, it has grown from just a facility into a facility and an idea. And as part of that idea, or this organization, we run, as Uli mentioned, the largest multidisciplinary client-sponsored capstone program in the world. So we have approximately 1,300 students and 250 projects a year. And these are client-sponsored projects. So students go in the course of a semester. So for us, about 15 weeks. They go through the entire design thinking process, which for us also includes prototyping. So the picture that you see here is from an end of the semester activity back in pre-COVID days, where students had the opportunity to show their work and the prototypes that they had built and talk about the process that they had used to the many visitors that we had. And in this particular picture, this is one of two rooms that run simultaneously because we are too big for just one. And so it's quite an event. But as I mentioned, we run these projects. I just want to run through a few of them from one semester to give you a sense of the kinds of things. So this is a cane that would sense different obstacles and different things in the environment and provide feedback to the user. This is work for John Deere, who makes tractors and other equipment for farms and yards and things. And we're redesigning the suspension system on a lawnmower. This is a product that ultimately was going to go into space that would help to manage pressure stuff there. This is a search and rescue robot. So when there are earthquakes and those kinds of things that would devastate a city, or a building, these little robots would be able to go in and explore the surrounding and map it out and help people, the rescuers, to understand what that environment looked like and how to move around in it. This is a young man who has a disease that affects his hands and legs, and we designed a new video game controller that he would be able to operate. This is a little bioreactor that the students designed. This is one of my all-time favorite projects. So our hockey team wanted a device that would shoot hockey pucks at the goalie so that the goalie could practice being a goalie. And so you can see this whole stream of hockey pucks that come down and the little wheel that kicks those out, and it moves them around so they shoot to different parts in the goal, and he could practice defending those. So you see that we have a wide range of projects, all the way from something very individual and personal, like a new video game controller, up to very large kinds of things. So and every one of these involves the steps in the design thinking process. So other things that the Learning Factory is involved with, we have a bunch of people that are affiliated with us, just besides just Menold and myself. We have teaching assistants, we have ambassadors that go around the college and university, helping people to understand the opportunities that are available to them in the Learning Factory, and they also help to organize events for us. We have Maker Fellows. These are graduate students with expertise in areas that are of particular interest to us. And we hire them to share their expertise with anyone who comes to use our facility. So for example, they might be really good at additive manufacturing, so some discipline within the College of Engineering. And then we have what we call our makers in residence. And these are people outside of the College of Engineering that have expertise that we find very interesting, that we invite to come and share their talents with us for a semester or two. So for example, we had a blacksmith. So we had a young woman up in one of our other colleges who was a blacksmith, and she was a maker in residence for us and came and taught courses on blacksmithing. And we believe that these different kinds of expertise round out the tool sets that are available to our students. So we want them to have as many tools in their toolkit as possible as they go about solving problems. We also have lots of different kinds of events. So the Learning Factory facility is open for students to come from 8 in the morning until 10 at night. They can come in and work on anything from a project related to a class to a present for their boyfriend or girlfriend or mom or sister or brother, to just kind of messing about in there. Now we have build nights where we teach particular activities. And so students can come, as I mentioned, for example, to come and learn about blacksmithing. We might have a build night on blacksmithing, or one on the Internet of Things, or one about a particular piece of software or a particular design thinking skill. We have Fudge Up Fridays. These are when people from academia or industry professionals come and talk about mistakes they've made and how they've recovered from those. Our students really suffer from a fear of messing up and making mistakes, and we want them to understand that mistakes are part of the process. And finally, make-a-thons. So these are short design, build, test activities where we go through the design thinking process in a very short period of time. For example, a few hours or 24 hours or a weekend. So that's just to give you a flavor of the kinds of things that we do in the Learning Factory. We also have, these, as I mentioned our in-person build nights. We also have virtual build nights. Some of you joined us for, we've actually had just a couple of these that we invited you to in the last few weeks. So some of you joined for Jared Butler. We had another one a week or two later. And these are, obviously we've had to move many things virtual. And so these are short, kind of 40-minute to 1 hour build activities that can be done in the comfort of your own home. If you're interested in getting on our mailing list for these, just send me an email at parkinson@psu.edu and we'll add you to our list, and you can join in any of those activities that we have. And I guess now is a good time to add, if you have questions as we're going along, you can throw those in the chat. And I don't know, maybe Steffi can monitor those and shout out if there's something that we need to hit along the way. Do you have questions so far about these different kinds of activities and things that we've talked about? All right. I can't see the chat, so I'm just, oh, wait, there we go. Ha, now I can see the chat. Okay, I can see the chat. So somebody give me at least one question so I know that there's people are paying attention. How many of you are there to run all these? That is a great question. So I assume you're talking about the projects. And so for our, we run those 1,300 students and 250 projects across 2 semesters. And so we split it roughly in half. And for each of those, we have about 20 faculty that help to manage the teams. As far as recruiting the projects, there are obviously myself, and then we have 3 kind of half-time faculty that help to recruit projects. As far as all the many other activities, there's lots of us. Let's see, can I tell you about the students, grads, undergrads, multidisciplinary from Penn State or other universities? Okay, so the students, the majority of these students that are participating are from the College of Engineering, although we have students from other disciplines related to engineering, and then students completely unrelated to engineering, all participating in capstone. So now we might have students from architecture or psychology or whatever. One of the great things about my particular situation is that we have within the College of Engineering so many students that we can invite students from other disciplines across the university to come and play in our sandbox, and we don't even know that they're there. For example, architecture, we have one of the top architecture programs in the world, and they have about 24 students a year. And so they could all come to use our facilities and participate in our programs, and we don't even know that they're there. Because we're running 1,200 engineering students through, and now those are just our seniors. You know, we still have 6,000 other engineering students that might come and use the Learning Factory as a makerspace. So we don't even know when students from these other disciplines come. So we can be very generous and open to them. And actually, one other interesting note on that, there's no fee to the students for using our facilities. So obviously, when they're doing something for their class projects, they can do that as part of the class, and we have structure around that. But you know, I mentioned, for example, we have a really cool embroidery machine, and we had a student this past week who was using the embroidery machine to make a set of towels for her sister who is graduating from high school. And that's all free to her. She brings in the towels, but she can use any of our facilities, our machines, any of that stuff for free. So we provide all of the resources and materials that students need to use the equipment. And one of the questions, how do we pay for that? We get donations from our sponsors. And so we run our projects very inexpensively. We know that many of you are able to charge, you know, 40 or 50,000 euro, for example, for a project. And we could do that for maybe the first, you know, 20 or 30 or 40 projects that we need, but I still need 200 more. And so we charge the amount that we can get for the 250th project, not for the first. So our projects run anywhere from $3,500 to $5,000, depending on the situation of the company and what their requirements are. So we run them very inexpensively. But those companies that are able to give us more, they still give us more. We ask them for that money in other ways, and we use that to underwrite the other activities that we do in the Learning Factory. The companies come to us, or do we hunt them down? We have a few that come to us that are long-term friends and sponsors, but we work very hard to hunt them down. It's a constant struggle recruiting projects. You know, as I said, you know, we can get the first bunch of projects fairly easily, and for us, probably the first 150 projects I can get pretty easily at this point. It's the last 100 that we need that are a lot of work, and that always comes down to the last minute. How do we create awareness? We have a huge alumni network. We're graduating a couple thousand engineers a year, and we leverage that very strongly. We also, Penn State is a very well-known university within the United States, and we use that name to get us in a lot of doors. And so that helps a lot. It also helps that we have most of the top companies in the world are at our university trying to recruit students. And so they're very interested in being engaged with us to get access to the students earlier. So we leverage that as well. How do we quality control the projects? That is a terrific question. We have a rule: we don't accept any perpetual motion machines. So any machine or projects that violate laws of thermodynamics, we reject those right off the top. So we probably get 2 or 3 of those every semester. But the rest of the projects, we work with the sponsors to take their idea and massage it into something that we think will be a good project. So we have a lot of experience with this, and a good sense for kind of the size and scope of projects that will work. And so there's a committee of faculty, myself and a couple others, that review each of the projects that come in and check the scope to make sure that they're good. Do I help getting the projects out? I do not teach the capstone program anymore. I did for a long time. I just don't have the time for it anymore. So I sponsor projects and I teach some other courses, but I don't teach that particular one. And how do we communicate with our sponsors? Our sponsors are very involved with the projects. We have weekly meetings with them. So each of the student teams meets with our sponsor every week for anywhere from a half hour to an hour, depending on the needs of the sponsor. They provide weekly updates on what they're doing and then discuss the different issues that they have. So, all right, great. I think we got through the first round of questions, and we'll hit more as we go on. Uli mentioned our new building, and I want to talk about this because this was an interesting opportunity for us to apply the design thinking process. So it's under construction right now. This is a picture of the construction site just a couple days ago before I left town. It will be 9,500 square meters, or 103,000 square feet, for those of you keeping score at home. And I want to go through the process that we use. So the first step was we had to win the building. We received approval from the university, the College of Engineering did, to build 2 new buildings. This building over here called West 1, and then this building right here called West 2. They were tearing down a number of older buildings on campus, and the plan was to move the people that were in the old buildings into the new buildings. The Learning Factory was not one of the buildings being torn down, and the Learning Factory is this little tiny building right here, and is about 4,000 square feet. So it's a very small facility, and it's frankly embarrassing. We came up with the name Learning Factory almost 30 years ago. We were one of the original learning factories in the United States. And in a recent article on a research paper on the top learning factory facilities in the country, we weren't even in the top 25. And that's terrible. The Learning Factory is the front door to the College of Engineering. We take people on tours. We do all kinds of amazing things with it, and it needs to be a world-class facility. And so I worked really hard to convince the university that even though we weren't one of the people that were being displaced as buildings were being torn down, that we needed to be at the top of the list for occupying one of the new spaces. And so the way that we did that was we used our most powerful weapons. First, shame. We pointed out how embarrassing our current facility was compared to places around the world. So we benchmarked with places in the United States and others and showed all these pictures of all these amazing places, and then how bad ours was in comparison. The second was our sponsors. So we have a lot of really important sponsors, and I have an advisory board, an industry advisory board, and I had them starting, they wrote letters to our dean, into the university and articulated in a number of venues how important it was that the Learning Factory be given one of the new facilities. And then finally, I got the students involved. And the students did a really phenomenal job of looking around at facilities around the country and then designing what they would like to have as a learning factory. And you can see this team here has even built a little scale model of one of the floors of a learning factory and what that might look like and what kinds of things it might have. And I gave them a table at our showcase at the end of the semester, along with the capstone projects, to let them talk about what the opportunity there was. And I knew that we had won and really scored some exciting points, and things were looking pretty good when our dean, this is the dean right here, stopped by and got the pitch from the students on the Learning Factory and why we needed a new space. And it was actually about 3 weeks after that that it was announced that the Learning Factory would be the primary tenants of the new building, much to the dismay of the people whose building was being torn down and didn't have a place to live. So that was a huge win for us and something that we've been really excited about. The next step was to provide direction to the architects. So the architects were named and we started to work with them on what this building might look like. And I finally had the opportunity to share pictures that I had been taking from around the world, and you will recognize some of your spaces. So here from HPI in Berlin. This is from HPI in Potsdam, or not in Potsdam, in South Africa, in Cape Town. This is another space outside of that down in Cape Town. This is from a place in Singapore. So I'd been taking pictures of facilities from around the world and documenting best practices. And I was able to share a very large document with our architects to give them an idea of the kinds of things that we were looking for. And then I also got the students involved. So I had the students identify kind of personas that they wanted to work towards, what their different influences were, some inspiration points, things that were interesting and exciting to them, and then had them turn that into spaces that they would like to see within the buildings. And so this student, for example, wanted something that was kind of like a cave, a place that they could go that would be inspiring in very natural ways, but that would also provide a kind of confined space that would minimize the distractions and outside influences. These guys wanted a very fun space with lots of different kinds of things going on in it that would be very invigorating. And I had a couple dozen of these that I provided to the architects. Well, it got reflected in some interesting ways. We let the architects start doing their thing, and it turns out the architects are very good at design thinking and have been doing a lot of this for a long time. So I mentioned at the beginning that one of the things we're trying to do is help our students get a lot of things in their toolbox. And I used that phrase with the architects of providing opportunities for the students to get tools in their toolbox. And they took this idea of an engineer's toolbox and used that as their metaphor for the building. And you can see a lot of that stuck. So this is the final rendering of the building. It has these little drawers that popped out on the side, like these guys right here. It has this very open front that allows you to look inside and see what all of the different tools are. But they kept that metaphor as they worked through things and had this idea of a space where students would be allowed to tinker and try things and make mistakes. They also really liked the ideas from the students about being inspired by nature and having, bringing the nature into the building. And they saw that cave and it reminded them of geodes. And so geodes are these rock-looking things that on the outside are very rough. But when you crack them open on the inside, they're very colorful and inspiring. And so they started to create these kind of geode spaces, and these have a very prominent place in our new building. So this is how they took that rough idea and started turning it into these spaces like the students had programmed, these kind of confined spaces that existed within this larger building. And here's a picture, a rendering of what these geodes might look like. Note the really rough outsides. with the windows to the inside with the interesting things going on in there. Just quickly to go through what the building ended up being. Down in the basement, we have a metal shop and a couple of computer labs and some spaces. Even though this is in the basement, there's natural light into these that comes through kind of a moat around the outside of it. On the first floor, there's a space for advanced additive manufacturing. There's a wood shop, a giant build space, and an electronics shop. On the second and third floors, we have two general purpose maker spaces that are adjacent to 8 design studios. So think HPI has on the upper floors has those big open spaces with lots of tables. We have essentially 8 of those within our building. And each one of those butts onto a maker space. So students can bounce back and forth between having an idea and working with Post-its and going into a space where they can work with to build more advanced prototypes. So using 3D printers, saws and cutters and lots of different kind of more advanced materials. And then the entire 4th floor is a 24-hour access makerspace that's available to the students. And it has those geodes up on top. So within this very hectic and inspiring environment, there are 4 of those geodes that have different kinds of spaces inside that the students can go in and work to different kinds of activities, work with teams in a very controlled space. We have a capture space where students can go in and take pictures of prototypes and make videos and these kinds of things. And then a couple of just very relaxing, quiet spaces. And here's a picture of it from above. So do you have questions about the building or anything related to that? It also has offices in it. So most of the design faculty will have their offices in this building, and the Learning Factory offices are moving in here as well. Hold on for a second and see if there are any questions. Do we provide training to students before using the stuff in the makerspace? That is a great question. Yes. So we have so many rules in the United States about how all this stuff works. We really want our students to be safe. So we have welders and band saws and table saws, and we have lots of ways for students to injure themselves. And so every student to even walk in the door, finally, they have to have an initial training. And this is safety training, but also a little bit of kind of social training that we're working on. We're adding to that now some psychological training to help them to be better teammates and to be nicer to each other when they're in the spaces. But we also have more advanced stuff. So we have multiple levels of, for example, milling, how to use the milling machines in the metal shop, and welding I mentioned, wood shop training, electronics training for using any of the stuff in the Internet of Things space. So yeah, we have very extensive training program, and I have a number of staff that are professionals in these areas that can help to train the students on that. Who finally decided on the design of the building? We did in collaboration with the architects. So the architects were awesome, and it was a very collaborative process. They would bring ideas back to us. We would pass those around with the different stakeholders and get feedback on things, and they would iterate on it with us. We had a number of constraints due to the location of the building. The shape of it was kind of fixed. And we were maximizing space. It can't be any bigger than it is. It can't be taller than it is due to some governmental restrictions. It can't be wider because there's buildings on either side. It can't be deeper because there's a building behind it and a green space in front of it. And so its box is set. And after that, we just, most of the creative options were what happened inside. How are we going to manage usage? We have, for example, the 24-hour access makerspace students can use as they will. In the other spaces, students card swipe in and we check their training to make sure that they're allowed to use the space. And then we have staff that are around to help provide assistance throughout. The building and teaching is not only open to engineering students. The engineering students will all take at least 2 classes in the building. So all of our freshmen, we teach about 2,000 freshmen a year, all take a course in design thinking. And so it's a 15-week course in design thinking training, and we introduce them to how to solve problems like engineers and the tools that we use as engineers to solve those. And this then becomes the backbone that we hang the rest of their engineering experiences on. And yes, we do track their training. It's associated with the card that they use. And so every training that they have gets logged, so we know who's allowed to use what equipment. How did we manage budgeting versus ideas on the building? That's a great question. We're actually under budget, so we should have aimed higher. It worked out pretty well. Because the size of the building was fixed, we were able to get pretty wild and crazy on the inside without affecting our budget too much. So things ended up being really nice. It has, for example, a wood floor that all through it that's going to be really cool, and a lot of really exciting things. So that all ended up working out pretty well. All right, we can come back to that stuff later. Here's just some renderings of stuff going on the inside, and you'll recognize some features from places like HPI in Potsdam and HPI in Cape Town and other places around the world. One of our design studios, the maker spaces are connected. They're in the front of the building and they're connected by stairs. So this is just one of the maker spaces without any equipment in it. This is a design studio. And this is a picture of the building in winter. We have lovely winters in State College, Pennsylvania. So that's what it's expected to look like. It will be done it will be completely finished in October of next year. So we've still got about a year and a couple of months left. So that's what I have on the building. I'm going to turn the time over to Jess now to talk about the research aspects.
Thanks, Matt. So at the Learning Factory, we do all sorts of really fun, awesome things where we're really enacting design thinking and design processes. And a big kind of awesome part of the Learning Factory is that we often collaborate with a lot of engineering design researchers from CEDTAP, which is a really interesting department in the College of Engineering. And so I'm kind of excited to talk to you guys today about some of the research that we're doing that's really at the forefront of design thinking. And so we like to claim that we're at the bleeding edge of design thinking research because we have this awesome group of people who spend their whole day thinking about how designers think. And so Matt, you can go on to the next slide. But I kind of conceptualize the way we look at our research and the way we approach research into 4 distinct areas. So some of our researchers in CEDTAP, we look at design thinking. So we try and understand how are humans going about designing, what are the processes involved, the cognitive processes specifically, and how does all of that, designer behavior and human behavior amalgamate to affect design outcomes. We also look at design processes, so investigating factors that affect the efficiency or the effectiveness of design processes, different types of design processes, so design thinking versus a different type of design approach, right, from TRIZ to other different methods. We look at the products that designers and design processes are making, right? So what's the outcome of all of these efforts? And finally, more recently, we've been trying to understand how design technologies are really affecting both the designers themselves, the design processes, and the products that are being designed. And so today I'm just going to talk through a few different studies that we've got going on that I find really interesting to kind of give you guys a taste of what's happening research-wise in the Learning Factory and at CEDTAP. So the first one is a study conducted by Scarlett Miller at Penn State and myself, and we were really trying to understand how design processes translate across cultures. So we asked this question: is design thinking lost in translation? So this started because we were running a design thinking and entrepreneurial workshop in Morocco. And as we were going about running this workshop, we realized that many of the design thinking research and the design thinking methods and processes that we've all come to know and love are really based on Western populations, Western studies, Western professors, Western ideals, right? So mainly Western and Northern European populations of students have been used in studies, right? So we were curious whether the things we teach in our classrooms really translate well across maybe into some different geographical and cultural regions. So next slide. Great. So we conducted a study where we looked at kind of the concept generation practices of Moroccan students, and we compared them to a US student sample. And what we found was that, first of all, culture really does affect just the fundamental way that designers problem solve. So there's, individualistic societies, which is kind of an American society is much more individualistic. You have communal societies. And so the way that they approach problem solving is inherently very different. And what our research highlighted was that certain cognitive biases, such as ownership bias, transcended culture. So we found that with ownership bias in particular, if an individual came up with an idea, they preferred that idea, right? They tended to like that idea better because they came up with it, regardless of the idea's goodness or originality or anything like that. So that kind of transcended culture, right? That was across cultures, we saw that. However, we had some gender effects occur. So in the US student sample, we found there were differences between men and women student designers, but we did not find those same tendencies in Moroccan student samples, which was really interesting. And this whole study really made us take a step back and think about how are we approaching design, and are we approaching design in a way that takes into account and celebrates the various cultures of the designers themselves. And so one person who's doing this really well in CEDTAP is Dr. D.K. Osei-Osari. So he's kind of on the next slide, his work. So he is leading efforts in Ghana. And so in Ghana, they have one of the largest technological scrapyards in the world. And so urban mining has become a really popular activity in this scrapyard, because it's actually now more efficient for us to mine our own waste for precious metals as compared to mining the earth. So you'll actually get more in terms of pure, mass from mining our own waste as you will from mining the earth. And so DK's work is really exploring how maker spaces and maker movements and designers are kind of being born out of this very unique scrapyard innovation playground. And the reason for that is because these individuals who are working in the scrapyard, who are mining different technologies from electronic waste, are coming to know these electronics, old computers, everything. They're getting to know them really, really well, to completely inside and out, because they're systematically unpacking them and looking for metals. And so because of that knowledge, it's spurring this really interesting maker movement where they are innovating and creating new designs and kind of have their own unique design process that is very localized and central to Ghana. There's designers in Ghana now making in the maker spaces that DK has kind of proliferated. They're making things from like barbecues to all sorts of crazy updated laptops. And it's just really interesting to watch these design processes evolve organically, as opposed to kind of going in and saying, hey, we're using the design thinking process, but instead letting them flow freely from kind of the resources available. So in addition to, looking at designers and how we're designing and the design thinking processes we're doing, we also are looking at, again, process of design, right? What's happening as designers are going through the problem solving process, as they're coming up with ideas. So one of my good colleagues and friends, Dr. Scarlett Miller, she has spent a lot of time looking at whether designers are actually filtering out good ideas or not. So within design thinking, we know we have tons of great ways to come up with interesting ideas, right? We have brainstorming, we have Triz, we have solo brainstorming, we have talking to users, collaborative design, and all of these things are great, right? They help designers come up with a ton of ideas that are really wild and crazy. And that's all wonderful, and it certainly supports innovation. But what Scarlett asks in her work is, if you don't select a good idea, if you don't select the crazy innovative idea, but instead, if designers are continuing to select the less innovative, less creative, and inherently less risky ideas, what's happening? How does that affect the design process? So she's conducted quite a few studies to look at this. Matt, you can go on to the next slide. And what she found was that there really is this innovation filter that exists. And so she saw that risk preferences and cognitive biases strongly predicted which ideas were getting filtered out during concept selection. And in particular, she was able to show that a designer's risk preference, so how much risk they were willing to take on, was strongly correlated with whether they would choose a truly innovative concept or not. And so, one thing we found was that really innovative concepts or creative concepts were being left on the table, and less innovative, less creative concepts were being chosen because they were more likely to be feasibly produced or feasibly come to fruition in the later stages of the design process. So this really helps highlight that in order to combat all of these biases, we need tools, we need methods to kind of support identification, not just identification of creative ideas, but also the promotion of those innovative and creative ideas throughout the process. So in addition to kind of looking at process, right, I mentioned we're also interested in how emergent technologies are changing the way we design. And I have a 3D printer on here because I think it is emblematic of some of the larger changes that design processes on the whole have faced. And what we're kind of seeing, at least, us as faculty and as engineering design researchers, is that more and more technologies are coming out for manufacturing that are really great for rapid prototyping as well. And so we're seeing these technologies creep earlier and earlier into the design process because they are so easy to use and they're kind of helping design become democratized, right? So 3D printing is a great example of that. And myself and a collaborator, Dr. Nicholas Meisel, are really interested in trying to understand how 3D printing is inherently changing the way that designers design. So we've conducted a few studies, and what we're finding on the next slide is that younger designers with more experience in additive manufacturing are potentially a little fixated on additive manufacturing, on 3D printing, because it's something, now high schoolers in the United States have 3D printers in their classrooms and are able to learn how to 3D print very quickly. And so because of this, we are seeing a tendency in our students, as well as in some designers, to leverage 3D printing earlier in the design process to create prototypes and kind of shy away or fail to use other physical prototyping technologies, which ultimately kind of affects the way they're designing the product itself. There are a lot of constraints with 3D printers that help you to either more efficiently make a print, or can result in what we call spaghetti if the print fails and it's kind of printing all over the place. And so designers and students in particular are kind of intuitively learning these rules as they more frequently use additive manufacturing. And instead of a design necessarily being guided by the customer's needs, it might start to be guided by the needs of the 3D printer. And that's when we can start to see problems emerge, right? We know in design thinking, right, your design process should be led by the customer's needs, not necessarily by the technology. And so we're very interested in understanding kind of what's happening here. How can we unpack this? And how can we mitigate some of these issues? And finally, another area of research that we're looking at is how do humans work with AI? So there's been a ton of advancements with artificial intelligence, and we see a lot of opportunity for AI to support designers, and for, in particular, to support maybe challenging group work. So engineering design teams, we know teams are necessary for really complex, challenging engineering problems. However, there's been a lot of research to show that teams on the whole often perform worse than the sum of their parts, meaning that individual designers can often outperform a team. There's lots of reasons for that, and it boils down to a lot of process issues. So social loafing and groupthink, all of these things contribute to inefficiencies at the team level. But if we can leverage artificial intelligence to identify those issues and try to kind of step in and intervene and mitigate them, then the effectiveness and the efficiency of a team increases, and we really start to get the benefits of a team, such as a diversity of knowledge, diversity of thought and ideas, right? So we're exploring, what are the different factors that affect the way humans are interacting with AI? So a lot of times in some of my own work, we're finding that they inherently don't trust artificial intelligent agents because, especially in face-to-face interactions, about 65% of information is actually exchanged non-verbally. And when you have an artificial intelligent agent that can only communicate through verbal cues, it makes it very challenging to inherently build trust in that agent from human to agent, right, perspective. So we're really trying to explore how we can more effectively leverage AI, and it boils down to how do you build trust? How do you build a lot of these very human feelings in an artificial agent?
Thanks,
so
Jess.
I think that's all I've got for in terms of research. Just a quick summary again, right? We're looking at design thinking, design processes, design products, and design technologies. We've lots of really cool stuff going on, and I would be happy to answer kind of any questions that folks might have for us.
Yeah, so this is the end of what we have. We, as I say on our next slide, we love to collaborate. If you're interested in participating in any of our remote build activities, or you want to know more about the research we do, send me an email and I can connect you with the right people. But yeah, so questions for Jess about the research stuff.
I think first of all,
Sure.
I would like to thank both of you. I don't see, okay, here. And I would like to ask all of our participants here to switch on your video if you like, because we now can enter into the verbal question and answer mode. And thank you, Jessica. Thank you, Matt. That was very, very comprehensive. That was a very tough run through your activities, and amazing what you're doing. Amazing new building. Really interesting research you are doing. So I'm happy to have you here today as our special guests here. And the floor is open now for questions. I have a ton of questions here. Some of them you were actually answering during the past talks, but please, I would open it to our guests. Who has a question to our both presenters? Maybe actually we start with the research activities, because Jessica was. Any questions so far? Kerstin.
Really, really, really impressive and amazing. I'm really thrilled what you shared with all of us. My question is, for me, it sounds like you put a lot of effort and also energy into all of what you are doing in the last years. So the question is to both of you, what is your key source of energy? Because you definitely put a lot of effort and energy in all of these activities, and I'm really curious how you do that.
Go ahead, Jess.
Yeah, sure. So I think we have a really great working environment at the Learning Factory. So it's it's a playground for students. You can definitely see that, right? There's lots of great stuff for them to learn, which is just kind of inherently invigorating to watch the students get excited about working with their hands and coming into the Learning Factory and working on real projects that they're excited about. But then also, I mean, for me as a junior faculty member, the Learning Factory has really been a playground for myself. So basically I can come to Matt and say, I would really love to run, Fudge Up Fridays. I think it would be great if we served students ice cream and we talked about failing, right? How fun would that be? And Matt is just such a great director of the Learning Factory, with a lot of really clear, kind of stronger vision for how things fit together, that he's always like, yeah, that sounds great. Let's give it a try. Let's experiment. And so I think that culture of just willing to try things out, and things certainly fail, right? Which is okay. We learn from it and we figure out how to do something better. But I think that culture makes it really lowers the activation energy needed to just try things.
Yeah, I would agree with Jess completely. Many of us have participated in improv workshops, and one of the first rules, and we do this in design thinking too, is yes and, right? And our goal is always to figure out how to say yes. And so what that has done is it has created an environment where we actually don't have to do that much work. I mean, don't get me wrong, we work a lot, but it's all fun. And there are tons of students and faculty that all have their fingers in it, everybody lifting just a little bit, because we have found a way to include them. So when people come to us and they want to be involved, we find a way to help them be involved. And that means, it's many hands make light work. And that's been our secret, I think.
Thank you. There's a question from Mats Danielsen from Open Lab in Stockholm. Do you do any research projects in social innovation?
Yes. So, yeah, Matt, if you want to answer that, you can go for it.
No, I'm saying you. That's all you. Go.
Yes, we definitely do. So part of my research is looking at startups and the processes that startups use to, how does that differ from, design processes in other areas, because they're inherently very resource constrained. And one aspect of that is looking at social startups in particular and trying to understand how they navigate both, traditional technological constraints of any tech startup, but also having this other social side. So yes, we do work with that. And then in addition to that, within CETAP, within the Learning Factory, we have the HESI program, which I would encourage folks to go look up. It's a wonderful program, humanitarian engineering and social entrepreneurship program. We also have a ton of great spaces downtown here in State College that really are more kind of social incubators and accelerators for those type of companies and businesses.
That leads me to another question to both of you. So you have set up such an impressive project-based learning environment there, and with a highly interesting track record through the past years. The Penn State University, and you're dealing with 1,300 students. The Penn State University is, I think, 80,000 students, are I'm not sure, but a way larger. So my question is, are you infecting other departments or the school itself with what you're doing, and how does that show?
Yeah, sure. That's a great question, Uli. So our 1,300 students are just our capstone students every year. So we have 2,000 freshmen and 4,000 other engineering students that all have the Learning Factory available to them. And certainly when we move into the new building, every one of those 2,000 students will walk through those doors and receive training in that space. So our contact is much higher. I'm on the advisory board for the College of Arts and Architecture, and we hire many of their students to participate with us. We collaborate with people from psychology, from law, from business. So we have friends and relations across the university. Theater, the Penn State Theater program. We have a set design program that designs and builds sets for Broadway. And so we have all kinds of people with their finger in this pot, kind of helping us out. So as I mentioned at the top, yeah, Penn State's 80,000 students. On our particular campus, we have about 40,000.
Is it just me realizing that Matt's?
Me too.
You do?
Yeah, me too.
Maybe Jessica, you can.
Yeah, I'll try and finish up.
Until his line is refreshing.
Yeah, while he hops back on. So we do have about 40,000 students at UPark. And so I think, as Matt was starting to say, we are actually not just for engineers. We work a lot with the College of Engineering, but we sit at the university level. So, students from all over are welcome and encouraged to come use the Learning Factory. And especially with a lot of our events like Build Nights, Fudge Up Fridays, all sorts of things like that, we are seeing a lot of students coming from human health and development. We have folks from comparative literature coming in and building couches and chairs and things like that. So I think that watching that kind of cross-pollination between fields and seeing what is coming out of it is just really fascinating for us, within the Learning Factory.
I'm back. Sorry.
Now we have Matt back again here.
I tried to finish your thought out, Matt, but I may have taken it in a different
Great,
direction.
Jess. I'm sure it was awesome.
So now actually we are at 5 o'clock sharp, and I would like to use that opportunity here to end the official part of our session here. And as I learned from Matt and Jess, you will have some more minutes for our kind of fireside private chat later after the 5 o'clock mark here. But officially, I would now thank you very much for being our guests here today and presenting the incredible activities at the Learning Factory, Penn State University. Thanks to Jessica and thanks to Matt, and a big applause to you, to both of you. Thank you very much. And I now would say goodbye to our listeners and watchers on YouTube, and we would stop also the recording. And then for all of you who are still interested, have some questions, please stay in the call here. Or the ones on YouTube who are willing, join the call here, join the Zoom call, and we have some more, maybe 20 minutes or so to discuss.